Of nonlinear equations. The reason you know they're nonlinear is you got x squared plus y squared. Hopefully from geometry we realize this is a circle. We immediately recognize the second thing as a line. You don't have to graph it, but it's nice if you can picture the circle and the line, right? And you know, and it's either going to hit 0 times, it might hit tangentially once, or it's going to hit twice. This one hits twice. What I do first is I know I'm going to do substitution. And I do this. I move y to the other side, since it was negative, and I write y equals 3x minus 2. I'm going to substitute b1 into the circle A. And I get x squared plus 3x minus 2 squared equals 4. Binomial squared is a trinomial. And this one works so pretty because numbers cancel. So if I take 4 away and combine like terms at the same time, I'm left with this. And this comes back to the age-old thing. You could always use quadratic formula, which we don't care for very much. You could complete the square, but don't do that until you check whether or not it factors. X is common. I can pull an x out. And now I have a product equals 0. And this comes back to when you have a times b equals 0, either a is 0 or b is 0. So we set both parts equal to 0. And I get x is 0 is one answer. I get x equals 6/5 is the other one. If I solve 10x minus 12, 0. Those are just my x coordinates. I have to find the y. Well, I'll use b1 down here. And I'll put 3 times 0 minus 2 equals y, which is -2. And here I get 3 times 6/5 minus 2 equals y. 18/5 minus 2, 18/5 minus 12/5, 6/5. Again, is that right? 8/5. That's what I meant, because 2 is not 12/5, it's 10/5. I was just checking it. What a lie, right? All right. And the answers are 0, -2, and 6/5, comma 8/5. Now, those are the two ordered pairs. If we go back up to my graph, which wasn't great, if I put it here, I think you can see 0, -2 at the point. And outside of being able to say 6/5, 8/5, that's in the first quadrant, that looks right. So we found 2 unknowns there. And again, if it hit twice, we need 2 points. The next one I want you to try is this one. It has 2 variables. It's definitely not linear because b times td is an order 2, okay? It's 2 variables multiplied, so it's not order 1. But it is solvable because there's b and td, and there's 2 unknowns and 2 equations. And obviously, since it's the first type of problem, it just jumped right out at you. The elimination works pretty nice here. And if we add these together, I can write this. Well, we can quickly see we divide both sides by 2. We can see that the product of b times td is 20. We don't know b, we don't know td, but we know its product. So what we use, we just use that knowledge back to the original equation. And I get 20 plus 5td equals 25. I move 20 to the other side, I get 5td equals 5. td has to be 1. Well, now I can use this along with the product. If td is 1 and btd is 20, I can replace this with 1. That makes b 20. And like you were saying before, we don't see this as x and y. We don't know which is the horizontal axis or which one's the vertical axis, right? So we can't make a point out of this, okay? You could solve by graphing, but you would have to choose, is TD the x-axis, the horizontal, and is B the vertical, or is it vice versa? And since you don't know, you don't write as an ordered pair. I will tell you this is set up on future problems. T stands for time most likely, and if it is time, time is almost always the x-axis, all right? So, now, you wouldn't know this yet, because the way we do this is we actually talk about graphing, or solving for graphing. Again, the top equation is a line, right? And that's the red line. This is an inverse function, actually, okay? And it looks like this. And the thing you got to recognize is that there is no point at x equals 0 or y equals 0. Because if you put a 0 in for x or y, you can never make 4. This is called an asymptote. The function does not exist at 0. And when x equals 0, there is no function. But you guys agree the red line gets the blue line twice? So we're going to find two solutions. Okay, we know that. We'll put that back up there. I'll solve the top equation for y. And then I'm going to put y, I'm going to replace y in the second equation with 2x plus 3. I get 2x squared plus 3x equals 4. If I check to see whether it factors, if I brought the forward and I check, the question is, does it factor? I think the answer is no. This is a prime. It's called prime quadratic, which means we have to complete the square. All right, so I check it, and then I just go to the process of completing the square. We divide everything by 2. And let's take a little reminder course on this. If you're going to have a square, a binomial square, you've got to have a trinomial here. We don't have a trinomial, but we know that the middle thing is a sum. Well, half of 3 halves is 3/4. And again, I get this by taking 1/2 times 3 halves. You take 3 halves divided by 2, but you get the reciprocal, so it's 1/2 times 3 halves. It's 3/4. The sum is 3 halves. The product here is 9/16. But I'm not allowed to just add it to one side. I got to add it to both. I use my calculator and get an improper value here. 32 plus 9 is a 41. 16th. And again, we should be pretty good once we see this. Take the square root of both sides, move 3/4 over. And I get negative 3/4 plus or minus 41 squared over square root of 4. Now, here's the disaster. Guys, those are the two x values. What do we have to find now? The y, exactly. And I'm going to separate these. I'm going to do them separate because I don't want to get confused. Because this will become sort of a disaster. Way at the top we had y equals 2x plus 3. So I'm going to put y equals 2x plus 3 under both of these. And I'll substitute that big disaster of an equation, or big disaster of an x value, I should say, in place. And now I'll distribute. 2 times negative points, this is going to be negative 3 halves, plus I think it's the square root of 41 over 2 plus 3. 2 of these are like terms. Again, your calculator will help you on this. 3 plus negative 3 halves. I get 3 halves plus the square root of 41 over 2 for y. When x is negative 3/4 plus square root of 41. All right. So I've done all this work. I can't even fit it on a 3/4 view. So my first point, how did I get 41? I had 2 plus 9/16. 3/4 times 3/4. Divide everything by 2. Yep, no problem. Oh, you know, it's early morning. It's not that I don't make plenty of mistakes. We'll leave it at that. All right, there's one point. Now you got to rinse and repeat, and you got to solve for the other y value. Now, here's one thing you really want to notice. When you do this, before you work this problem all the way down, I want you guys to look here and here. You guys notice the only difference between these two is the sign on the radical portion, right? Listen, since that's the only difference, we can skip down here and know that that the whole number portion, the rational portion, is going to stay the same, and the only difference then will be that sign. Save you some work. If you're not sure right now until you see that from practice, you can do that. I'm too lazy this morning, and I want the video not to be much longer than 10 minutes. And we just found the exact 2 points of intersection. All right? And that means that is the 2 points on the red line. And you think about it. We look here. This one here is on the right side of the y-axis, on the first quadrant. This one is on the left side, it's negative. We found our 2 points of intersection.